All right, folks, so here's a review on two problems that are not on the Reese problems packet, okay, that are very similar in concept to what might be on tomorrow's part 2 tests. Okay, so here we have a function over here, and obviously you would need a calculator on this, okay, and so the point of this problem is to be able to use the functions on the calculator, which you should know by now, especially from last year's classes, but it's okay, we'll review it right now. So the first thing I'm going to do, let's cheat and use Desmos to get the big picture of these, and then we'll go back and zoom in on using the graphing calculator specifically. Okay, so when I put this on Desmos, okay, I get this right here. And some key points to note is this, and this right here. And I think here what I should have done was put some more points here. So let's get 4 points, get these 4. All right, and let me copy and paste those here and go back over here. Boom, here you go. Okay, you get this, this is that, this is that, and this is that, and this is that, I think. Nope, this is that. Let me use better colors over here. This point is that. Well, we'll revisit it if we need to, so I don't have to waste your time with just colors of a highlight. So remember, this is the graph right here of f prime. All right, this is the graph of f prime. And one thing I should say, another thing that I also mentioned on the assignment for today, is to review 11 Thursday, 11 Friday, not the free response question from 11 Friday, because tomorrow's part 2 test will be emphasizing and focusing more on the graphical analysis of things. Okay, so again, this is the graph of f prime over here, which is the graph of slopes. Okay, graph of f prime equals the graph of slopes. Okay, now, and same thing over here, graph of f prime. Let me put a space here. So now, the intervals on which f is increasing, decreasing, let me also get this classic slide over here that I've shown many, many times by now. Boom, concepts. Let's get this here. Where is it? There it is. Okay, we've seen this graph many times. Okay, now, where f is increasing and decreasing, okay, where f is increasing and decreasing is where the slopes are positive for when f is decreasing and when the slopes are negative, okay? So here we have the slopes are, remember, this is the graph of slopes. The slopes are positive here, so that's when f is decreasing, and also the slopes are positive here, and that's when, oh, whoops, I misspoke. Here the slopes are in the positive area, so that's when slopes are increasing, and so is it over here. It's where both of these blue areas is where the slopes are positive, so that's where f is increasing, okay? And so that is why in between 0 and 0.052 is this blue, and in between 1.384 and 3.17 is right here, and that should be matching up on the answer key, okay? Let's see, so between 0 and A, which is 0 and 0.42, so let's see if that matches here. Okay, 0.42, there's a little bit of a discrepancy, okay? I think it's just an estimation thing over here. And E, 2.75. Why is there a discrepancy between my graph? X plus 10, why is it X plus 10? over here divided by 5. Okay, there might be a mistake on this one over here. I think there's a 2.75. See, I don't know why in this equation there was a divided by 5 over here, because that's not in the original. That's not in the original. Okay, so let's just do this manually over here. I'll create the answer key as I go over here. Okay, so here we go. Okay, so anyways, so let me change this real quick to green. I'll change this to orange actually. Okay, and this is to describe where it's increasing, where it's positive slopes, where this graph of slopes is positive, is going to be between these 2 points and these 2 points to describe, okay, these oranges here. So we're going to get in between 0 and 0.502, okay? So F increasing in between 0, okay, in the interval 0 to 0.502, and, okay, and then 1.384 to 1.384 to 3.171, okay? And then F is decreasing, okay? F is decreasing right here. F is decreasing between, it's going to be decreasing here at this orange. Okay, let's get rid of these right here. Okay, I'm going to get rid of that and that. Let's get rid of this, this, and this. Is going to be decreasing here because that's when the graph of slopes is negative. So it's going to be in between 0.5, okay, 0.502 and 1.384, okay? So 0.502 and 1.384, okay? And that's where it's decreasing, and that's A, okay? So where the minimum and maximum occurs, okay? Where the minimum and maximum occurs is basically at the x-intercepts, okay? So we have an x-intercept here, okay? And here the slopes are positive up until this point right here, okay? Up until this point right here, the slopes are positive, positive, positive for F. Okay, so let me just go back to this slide right here. We have a maximum, okay, where the slopes are positive in the graph of F. This is the graph of F, remember, where the slopes are positive, 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 and then it switches to negative. Where the slopes are negative, 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 switches to positive, that's where we have a minimum, okay? So here, the slopes are positive, 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 then switches to negative. So this right here is going to be a maximum because it's positive, 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 switches to negative. That's a maximum. So this is a maximum. Then it goes from negative, negative, negative to positive. So this is a minimum. Okay, so maximum here, minimum there. So your maximum, okay, is going to be your maximum is going to be at this point here, which is 0.052 or 0.502. 0. Max x equals to 0.502. And we also have a max at 1.384, which is this point over here that I meant min. Okay, min x equals to 1.384. Okay? So C, with the intervals where it's concave up and concave down. So if we look back over here, all right, it's concave up, okay? It's concave up when the slopes, when the change in slopes, okay? So let me say this. Let me put it this way. This is pink is concave down because slopes are decreasing, okay? Slopes are decreasing. And here, this is concave up because slopes are increasing, okay? So here, here, this is the graph of slopes. So slopes is decreasing here. So that's when it's concave down. And slopes is increasing here, and that's where it's concave up. All right? So I'm going to say for C, it is concave up, okay, at concave down from 0 at 0 to this point over here, which is 0.863, 0.863, and it is concave up from this point to that point, which is 0.863 to 3.171, 0.863 to 3.171, okay? So again, I'm reflecting this concave down, concave up, concave down, concave up, because remember, concave down is where the slopes are decreasing, okay, 5 to 4 to 1 to 0 to -1 to -4, and concave up is when slopes are increasing, okay, 0, 1 to 4, or -4, -1, 0, 1, 4, okay? And D, the points of inflection, is where we have a change in concavity, okay? We have a change in concavity, so watch this. So let me, again, get rid of these highlights over here, okay? We have, remember, this was concave down, this was concave up, and we have a change in concavity here. Remember, in the graph of f prime, I said before, your inflection points is the humps, okay, is the humps of the f in the graph of f prime, whereas they are the x-intercepts in the graph of f double prime, where the x-intercepts change from positive to negative or vice versa. So again, this hump right here is going to be 0.863, okay, 0.863. So inflection point at x equals to 0.863, okay? Now, let's go ahead and use our graphing calculator for this. So I went ahead and put this same equation that you see right here into the graphing calculator. So here, I'm going to start scrolling right so you can copy what I did. I put this 1/3 in parentheses just to be safe, okay? All right. So I'm going to scroll again from left to right so you can copy that. Okay, 1 minus 2, okay? All right. If you want to go half speed to here, let me just go slower this time. If you want to go half speed, well, you don't need to because I'm going slower this time. Okay. Now I go. I like to go zoom 6 to get just a general gist of how this is going to look like. Okay. All right. Now it says the open interval of 0 to pi, so what I'm going to do is set my window of x min to 0, x max to pi, okay, and boom, and I'm going to go graph, all right, and that basically takes our graph from the black to the green line over here, all right, right there. And maybe for your y, what I want to do is change your y, just to zoom, make it more longer, top to bottom. I'll maybe zoom in on the y. I'll go maybe -5 to +5 hit graph. Okay. And now, if you want to find Desmos is cool because all you have to do is hover over these key points to find out what they are. Okay. But if you want to find it manually, do not just go trace and find it like that, Okay, those are estimations. To get a better estimation, for example, let's say we want to find this left point. Okay, this left point right here. What we do is, well, in this case, you can do a couple things. Okay, let's see what happens if we go second trace to access calc and go maximum. Let's see what happens here. Left bound. Okay. You know, a better thing to do for the left side and the right side, okay, for the left side and the right side is just to simply use your table. So second window, or excuse me, no, go back to graph and just literally, you know the x coordinate's 0, so just go 0, whoops, go, where is it? There's a way to enter in 0 here. Where is it? Second. Hold on. Graph. Oh, I got it. My bad. You hit trace, and then we know the x coordinate is 0, so let's see what it spits out at 0. 1.381, and that's what we got here. And if you want this point right here, which is the end point, which is the end of the interval, which is pi, just go trace, okay, and then hit pi, which is second here, and then it spits out the 0.949, which is there, okay? And so that gives us the endpoints. If you want to find the x-intercepts over here, okay, I go second trace, and then go to, for x-intercepts, it's basically zeros, okay? And right now, the calculator is it doesn't know where to look for the x-intercept, so we're going to narrow it down, okay? I'm going to set up a left wall over here, okay? Left bound, that's a left wall. And then I'm going to set a right wall over on the right side here so that we can tell the calculator to look between these two walls and then press enter. And then it's going to give us this x-intercept, which is 1.384, which matches up here. That's this x-intercept. Okay, and we can do the same thing, same exact process with this x-intercept, set a right wall, left wall somewhere here, right wall somewhere there to find that x-intercept. And if you want to find this minimum right here, we do the same thing, second trace, and go to minimum, all right? And then we just do the same exact thing, left bound, okay, right here, right bound, right here, okay, boom, and guess it. And we should get 1.38, or excuse me, 0.8633, which lines up with this, okay? So basically, we just set the window, in summary, we set the window based on the interval, okay, because it was 0 pi, all right? That's what I did for my x min was 0, x max was pi, y min to zoom in vertically, instead of -1010, I did -5.5, okay? And then after that, I just hit graph, and to get these key values of the x-intercepts minimum maximum, I do second trace to access calc and use zeros minimum max. And that's really what you'll need tomorrow, just option 2, 3, or 4, okay? Now, again, to get the endpoints over here, I just press trace and press 0 because that's the left interval, the left side of the interval, and it spits out 0, 1.381, which is here. And then I press trace again to get this side and press pi, which is second here, press enter, and I get 0.949, 3.14, and 0.949, which is here. Again, it's not a perfect match to decimals, but it's close enough. Okay, and just use those key points to determine what's going on over here. Okay, and so these were your answers. Now let's look at number 8. The second derivative function is this. So I'm going to put number 8 on Desmos. Okay, and let's go like that. And on Desmos, it was x times 2 to the power x minus 1. So I'm going to go like this: x times 2 to the power x minus 1. Okay, and it looks like this. Let's just get these key points. We probably only need this one, to be honest with you. Okay, but let's just get all three just in case. We probably just need that 0.641. Okay, so this is your graph of your second derivative. Okay, let me just separate these problems out here. And Okay, now, remember, this is the graph of f prime, which is graph of f prime, graph of slopes, or graph of change in slopes, depending on how you want to. We're just doing a play on words to help us interpret it. Okay, let me go like this, equals to, like that, and let's go equals to, like that. All right. Now, so we're looking for where f is concave up. So again, if we go back to the graph that I have a million times, so if you're concave up, means the change in slopes is positive. Okay, slopes are changing for the slopes are changing in a positive direction. Slopes are increasing. Look, -4, -1, 0, 1, 4. So slopes are increasing or slopes are changing in a we're looking for where the change in slopes is positive. Okay, so again, let me just say that play on words real quick. Concave up is where change in slopes is positive. Okay, so this is the graph in change in slope. So we're looking for where it's positive. Okay, and it's right here. All right, that's where it's concave up. Okay, and so your answer would be your answer would be 0.641. It is concave up in at this x interval of 0.641 to positive infinity. Okay, a concave up in open or in closed interval, or let's just say in interval of, okay, so something like that. And if it's concave down, it was asking for concave down, we're looking for where the change in slopes is negative, okay, because it's decreasing, so the change in slopes is going in the negative direction. Okay, it's decreasing, 5, 4, 1, 0, -4, blah, blah, blah. Okay, so we would be looking in that case, if it's concave down, it is this right here. All right, it's that right there. Okay, and this would be in the f double prime case, this would be an inflection point because it's an x-intercept and it's changing from negative to positive, or concave down to concave up. Again, this is an inflection point which changes in this case from concave down to concave up. Okay, and let's see if this matches your answer key. The answer key over here, 0.641. This one happens to match. Okay, the other one did not match for some reason. Okay, and again, I think it's because it's this typo right here of divided by 5. I don't know what that was about right there. Okay, that's why these numbers are off over here. But anyways, this was a more clear answer key, I believe, right here. Okay, so hopefully that answers your question, folks. Please practice the calculator functions that I outlined, all right, earlier in the video. And thanks for tuning in.